Hi, everybody. Sorry I'm not there today. Had some stuff going on, needed a day off. What we're doing today is not like a huge extension of what you already know how to do. We practiced factoring on Friday, and that's a big part of this. If you struggle today, please do not worry, because we're going to talk about it tomorrow before we move on, okay? All right, so rational expressions. Now, this isn't a function, it's just an expression. There's no equal sign. A rational expression is a ratio of two polynomial expressions. And remember, a ratio is like a fraction, which is division. And P of x and Q of x are polynomials. Just like simple fractions, rational exponents are not in simplest form until there are no common factors between the two polynomials. And that's where our factoring practice is going to come in. Oops. So simplifying rational expressions, it's not too difficult. To simplify a rational expression, you're going to break each polynomial down into its factors, then cancel the factors that match in the numerator and the denominator. So remember, anything divided by itself is 1. And when we multiply by 1, that's the multiplicative identity. So it kind of just mushes in with everything. We do have to ask ourselves, okay, so hold on. So if you look here, 6 over 8, that can be broken down. This is a very simple explanation, or a simple example. 6 over 8, they both have a factor of 2. So you can break those into 2 times 3 and 2 times 4, cancel out the 2's, and you get 3 over 4. And that's the process we go through in our heads when we simplify a fraction. Now, if you look here at the rational expression, I have x squared plus 2x minus 3 over x squared minus 4x minus 21. I factor both of those using the snowflake if I need to. And then I see that I have x plus 3 over x plus 3. And those are going to cancel, and I'm left with x minus 1 over x minus 7. Now, I don't want to fully talk about this today because it can get confusing, but we need to be looking at these expressions and deciding if there's any number that x should not equal. Okay, so add this to your notes somewhere. Remember, the denominator of a fraction can never equal 0. Okay, so we're just going to keep that in mind for right now. And next week we'll talk more about what x cannot equal. But remember, the denominator can never equal 0. Okay. So here's an example of simplifying rational expressions. I liked this because it has all the steps. If you look how they factored this one on the bottom, you'll notice that they saw that these 3 terms all had a 2x in common, and they pulled that out. And then that makes this that you have to factor in the parentheses just a little bit easier. You don't have to use the snowflake anymore. Okay, so now we go through the same process. We factor the top, we factor the bottom, and then we're going to cancel out whatever matches. Okay, because anything divided by itself equals 1. And then you're just going to write what's left and simplify. And no, here, you do not have to distribute that. Let's write that. Do not need... Oops, I can spell. To distribute here. Okay, so that would be your final answer. Again, we need to think, is there any number that x cannot equal? So we're just going to remind ourselves again, the denominator cannot equal 0. Okay, oops. So one of the issues that some students have with these problems is they don't always look the same. Sometimes you're going to have binomials. Sometimes you'll have difference of perfect squares. Sometimes you have a trinomial. Sometimes you have to use the snowflake. Sometimes you don't. There's a lot to take in. I have found that these problems here, where students have to factor binomials, prove to be the toughest. And I think that's just because we're so used to factoring the other way. But we'll talk about that and practice a little more in class tomorrow. Okay, so here's some examples for simplifying. I need to simplify the top, simplify the bottom. The top looks like I could do this and reason through it, or I could use the snowflake. Either way, it looks here like I am looking for factors of 15 that multiply to 56. No, sorry. Oh my gosh, I said that wrong. I'm too far into the video to start over. I'm sorry. I need factors of 56, two numbers that multiply to 56 that add to 15. Well, one of my favorite multiplication facts is 7 times 8 is 56. I always remember because it goes 5, 6, 7, 8. They're both positive, so I'm going to add in both parentheses. And then on the bottom, I noticed that these are both perfect squares, and I have a difference. Okay? These are difference of perfect squares. My goodness. So this is going to be r plus 7, r minus 7. If that doesn't come naturally to you, you probably want to be looking into it because we're going to be seeing a lot of difference of perfect squares this bundle. So write this formula in your notes if you need to. A squared minus b squared equals a plus b, a minus b. If you need help with that, let me know and I can go over some of it with you tomorrow. Okay, so now I'm going to cancel out the matching terms, and then I'm going to write what's left. Okay, and that's my answer. It's not too bad. I think you guys will do all right. Okay. All right, let's try another one. So when we have binomials to factor, I've noticed that we struggle a little bit with that. So what you want to do is ask yourself, let's write something here. Biggest thing they have in common. Okay, so it looks here like these two, the biggest thing they have in common is a 5. So I'm going to take that out and then divide what's left divided by 5 and put that in the parentheses. Now on the bottom, I have a trinomial, and that's going to factor into 2 binomials. I know R and R. It's the only thing that'll give me R squared. I need factors of positive 6 that add to positive 5. I'm going to go with 2 and 3, which is good for my problem because there's an R plus 3 on the top, so I'm hoping those things will cancel. And they do. Okay. And I'm left with 5 over R plus 2. Okay. So those are just some simple examples of simplifying rational expressions. We need to take it a couple steps further. We need to do multiplying rational expressions, and we also need to do dividing. So today you are going to look at multiplying rational expressions because it's not super different. There's just a little bit more factoring involved. Our first step, again, when we're multiplying rational expressions, is going to be to factor both the numerator and the denominator. The first thing you should always do is just factor everything you see. When multiplying fractions, remember we multiply straight across the top and straight across the bottom. Because of this, we are allowed to cancel across the multiplication sign. Okay. And here's a couple examples of what that would look like. So if you see here, I have binomials and trinomials mixed in this problem. I simplify each fraction as best I can, factor whatever they have in common out, and then cancel what's left. If all the algebraic factors cancel, you are just left with the numbers. And if those numbers, say, instead of 8 over 3, we had 16 over 6, you would need to simplify that. Okay. Now this one, here's another one where we have binomials here, trinomial, binomial. This time in the binomials, you can actually pull out a 3x squared. So really make sure that you're taking out everything they have in common. What you have left in the parentheses should only be linear factors, which means it's x to the first power. Okay. So here's an example. The first thing I want to do is just factor everything. So upstairs here, I have 100. I need factors of 100, multiply to 100, add to 20. I'm going to go with 10 and 10. N plus 10, N plus 10. 10 plus 10 is 20. 10 times 10 is 100. Okay, good. Got that one. Now I'm going to look at the denominator. And I see that they have a 9 in common. So I'm going to divide out a 9. And I'm left inside with n minus 6. I still have to factor the other fraction here. So this one's going to factor like this. And I need factors of negative 12 that add to negative 4. So 6, 2, 3, 4. I'm going to go with 6 and 2. I know it's n and n. It's negative 12, so my signs are different. And then 4, negative 4. So negative 6 and positive 2. Same thing down here. Let's see. They need to add to 12, multiply to 20. I'm doing 10 and 2. Okay. So that's how that one should be factored. And now I'm going to go through and cancel whatever I can. So I see n minus 6 has a match. N plus 2 has a match. And now I kind of have this dilemma. I have 2 n plus 10s on top and 1 n plus 10 on the bottom. They cannot all cancel. Okay? 1 n plus 10 cancels with 1 n plus 10. So let's write a little note here. I want us to say, notice the n plus 10 on top only cancels 1 n plus 10 on the bottom. That's super, super important to remember. Okay. So even though there was an n plus 10 in the denominator, we're still going to have an n plus 10 in our answer. So our answer is just whatever's left. This is on top. This is on the bottom. Okay. So really multiplying rational expressions is not a big jump in skills from what we did with simplifying. All right. Oh, stinkers. Okay, so this on your notes, I gotta fix this here. Bear with me, because this should say (35m to the third plus 49m squared). Okay. So again, we need to factor this. That should be right on your note guide, that 35m to the third. Okay, so we need to factor. It looks like up here, I'm going to need to use the snowflake because I have that 5 in front of my squared term. My a is not 1. So snowflake, get your notes out from Friday if you don't know the formula or the setup. 5 times 14, I believe, is 70. I'm going to double check because I'm not sure. It might be 5 times 6. 5 times 15. Yep, 70. Okay. I knew that yesterday, but today it's 5:30 in the morning. Okay, so that's 70. And then I have 17. And 5 and 5. My iPad doesn't like it when I move it around a lot. Okay. So I need factors of 70 that add to 17. Hopefully that one's pretty easy for you guys. 7 times 10. Okay. Over here, We need to divide by 2. Sorry, we need to divide by 5, and that gives us 1 over 2. So this makes this, I wish my iPad would work, 5x plus 7. I'm sorry if we're not using x's. That's just what I wrote. And then x plus 2. Oh, it's m's. Okay. All right, so I really need to fix my pen here. Ooh. Bear with me, guys. This is going to take a second. Okay, let's see if this works any better. No. I might have to swipe out a bit. Technical difficulties. Okay. Let's see if this is better now. All right, here we are. So now I'm going to rewrite these fractions in factored form. There we go. And I'm going to use m's. 5m plus 7 times m plus 2 over 7m times 7m squared over, so that looks like a 7 can come out and 2 m's. And then when I divide that out, remember this is what you're doing. You're going to have 5m plus 7. All right. So now once you've factored everything, you just need to cancel. And remember, we can cancel across the multiplication sign now if we need to. All right. So I'm going to cancel everything that matches. And then I have m plus 2 over 7m. Okay, one more example. Last one. This one's got all kinds of stuff going on. I see a binomial here, but the terms don't have anything in common. It's difference of perfect squares. I see it. And 9, okay, so this is almost difference of perfect squares downstairs, but this 81 has an x on it, so that's not difference of perfect squares. So square root of 49 is 7, x plus 7, x minus 7 is how that factors. Down here, it looks like I can take out a 9x from each of these. And then inside I'll be left with x minus 9. 81 divided by 9, yeah. And then here we're going to multiply. X minus 10 is on the top. And then on the bottom, I need factors of positive 70 that add to negative 17. So I'm going to change these around. Okay. Oops. We're going to cancel anything that matches, remembering that we can cancel across the multiplication sign. And then we just write what's left. So x plus 7 on the top and 9x times x minus 9 on the bottom. And I know that you could distribute that 9x on the bottom, but this is how we want our answers written in simplest factored form. Okay. All right, I'm trying to think if there's anything else I need to tell you guys. You have a worksheet today. It's 10 problems. What we'll do tomorrow is we will recap all of this, and I'll take your questions. We'll do a couple examples, and then I'm going to quick show you how to divide, and you'll just get a few more problems, not very many. Okay, I hope this was all right for you. I will see you tomorrow. Good luck.